Alright, this chapter 12D is about the sine rule. So in any triangle ABC, the sine rule is essentially, it's basically saying that the ratio of the side and the sine of the opposite angle is always the same. So for example, the side here is A and the opposite angle. Now opposite is the angle that is looking at the side here, right? If this is this angle here, then that's an adjacent angle because that's next to, right? The side makes up the angle, so that's adjacent. This is also adjacent angle. So opposite is this angle here. Okay, so when you draw a triangle, any triangle, if I change up the label, so ABC, then I start at the point B, that side, the opposite side, the length B would be here. And if I start at point C, the opposite side, the length C, with length C would be here. Similarly, the last one would be here, okay? But regardless, it's the ratio of the side. In this case, A would be here, and the sine of the opposite angle, which is angle A, will always be the same. So you see, if it's B over sine B, that will also be the same. And this is how we can use the sine rule to find missing angles or sides. All right, let's have a look at this example here. So find correct to two decimal places. Question A is AC. Now, let's have a look at the side AC here. What's the opposite angle? Do we know that? Yes, the opposite angle is 76 degrees. And do we have another side and opposite angle? Yes, we do. This side here is 9 centimeters and the opposite angle is 58 degrees. Okay, so let's start with that. So we've got, for question A, we've got AC over sine of the opposite angle, which is 76 degrees, equals 2. And then the other pair would be 9 over sine of its opposite angle, which is 58 degrees. Now we've got all numbers in here and the only missing value is AC. So we can actually just work that out now. Using the cross multiply rule, or you can just think of it as multiply both sides by sine 76, so that will just go in here. So I've got AC is equals to 9 sine 76 degrees over sine of 58 degrees. Punch that into the calculator, and you should get 10.297. Okay, so again, I'll write it in 2974 actually. I write it in 4 decimal places and then I'll write the answer. Therefore, AC is 10.30 centimeters. So 2 decimal places. And then we want to find BC. Okay, so let's erase this shape here. BC, the opposite angle is A. We don't actually know the opposite angle. But can we find it out? Yes, this angle here is just 180, the sum of all angles in the triangle minus the other 2. And that one would just be, when you do the subtraction, it would just be 46 degrees. So now we can put 46 degrees in here, and then we can work out the side BC. Okay, so similarly, BC over sine of the opposite angle, which is 46 degrees, would be equals to, you can choose any pair, but I prefer the pair here that has the exact value. So that would be 9 over sine of 58 degrees. Alright, so punch into the calculator. BC would be 9 times by sine 46 degrees. Again, just times that to here. Times that across, right? That will be sine of 58 at the bottom. So punch that into the calculator, and you will get 7.6341. So then the answer BC to 2 decimal places will be 7.63 centimeters. Alright, for a question like this where we don't have any diagram, you actually have to draw it out from 2 points A and B, which are 80 meters apart on a straight north-south. Okay, north-south road, A and B, a straight north-south road. Okay, so bearings of a house are 125 and 50 degrees respectively to the 2 points A and B. So let's try it out. So north-south, this is north. Alright, let's say point A is here. Okay, so let's say the point A is here, and the house is 125t from point A, which is like around here. So that's 125 true bearing. Remember, the bearing is always clockwise from the north line, so 125 degrees. And then point B, the bearing will be 50 degrees. So from point B, it will be 50 degrees. So that angle is 50. All right, so find how far each point is from the house, correct to the nearest meter. A and B are 800 meters apart. This is one of those things where we can actually find out all the angles. So 125 degrees here means that this one here would be 180 minus that, and that would be 55 degrees. All right. Then do we have all the angles? No, because that's the side. The opposite angle is this one. We actually don't know this one. So let's just work that one out. Well, technically you can just use the exterior angle theorem, where the external angle is the sum of the two internal angles. So that one would be plus 50 would be 125, so that's 75 degrees. Or you can go 180 minus 55 minus 50 degrees, and the answer should be the same, 75 degrees. Okay, so now we've got the opposite angle, and we need to find how far each point is from the house. So let's say H, the house is H. So we need to find AH and BH. Okay, so using the sine rule, you would have AH over sine of the opposite angle. So again, AH is here, opposite angle is 50 degrees. Right, then that would be the same as the side that we know, which is 800 over the opposite angle, which is sine of the opposite angle, which is 75 degrees. Punch that into the calculator, you get the answer for AH, which should be, we want to correct to the nearest meter, so 634.45 to the nearest meter would be 634 meters. And very similarly, BH over the opposite angle. So BH is here, so the opposite angle is 55 degrees. So BH over the opposite angle sine of 55 degrees would be the one that we know, which is 800 over sine 75 degrees. Same thing, punch into the calculator and you get your answer, which should be 678 to the nearest meter. That's just the final answer, so I can just use these answers straight away. All right, let's now we can actually use the sine rule to find the missing angle in the triangle. Okay, so for example, in this case, the missing angle is theta. We can use the inverse of like a slightly different rule. So you know how we have a over sine A is the same as b over sine b. We can actually flip that around and have sine of a over a first equals to sine of b over b. Right? It's like saying 1 over 2 is the same as 4 over 8, right? And when you flip that around, 2 over 1 is the same as 8 over 4, right? It's the same thing here. So we can flip that, and the idea is that if you're finding an angle, you want to use the version where the angles are on top, right? You see why in a second. So we'll use this version here of the sine rule. So sine of theta would be, sine of theta over the opposite side, which is 8. Right, would be sine of 75 and the opposite side 12. So that'll be sine of 75 degrees over the opposite side 12. Now the reason why I want to keep this angle on top is because I can easily multiply 8 from the bottom to the other side. Okay, otherwise you have to do some flipping, and that would be a bit strange. So sine theta would be 8 sine 75 degrees over 12. And then theta would be inverse sine of that whole expression here, 8 sine 75 degrees over 12. Just punch this whole thing into the calculator. The answer to this should be 40 point, let's see how, nearest degree. So 40 point, technically it's 40.087, which is to the nearest degree is 40 degrees. All right. Lastly, let's have a look at example 10. Find the length OC correct to 1 decimal place. So we don't have all the information yet. That means that we need to try to solve for a few other things first before we can solve for H. Okay. For example, in this case, we probably want to solve for X first, and then we can find H after. All right. So to solve for X, X is the opposite side of 32 degrees. We have this side here, which is 12, but we don't have the other angle, ACB. So let's try to find the angle ACB. We can use the exterior angle theorem. So that's the exterior angle will be equals to the sum of the two interior angle. So then you get 70 degrees is 30 degrees, and then 32 degrees plus angle ACB. Okay, so then subtract that over, that'll be 38 degrees is equals to the angle ACB. All right, so let's put that one in here. So that's 38 degrees. So then we can try to solve for X first. So we'll use a version where the side is on top. X over sine 32 degrees would be equals to the side that we know, 12 over the sine of the opposite angle, 38 degrees. Okay, so punch that into the calculator, you get x value, which should be 10.32878. I'll go more decimal places here. Technically, if they want one decimal place, you only need to go two more, which is 32, and then that will be 329. And just go two more decimal places and you should be all right. All right, now we want to solve for h. So in this case, CBO, if we were to redraw CBO here, CB is x, so that's 10.329. And then h is here, and right angle triangle, 70 degrees. You don't even need to use the sine rule, because that's just the opposite over hypotenuse, right? Opposite over hypotenuse. So, all right, use the so rule. So sine of 70 degrees would be equals to h over 10.329. So then h would be times that to the other side, 10.329 sine of 70 degrees. And to three decimal places, that would be 9.706. And then, so that to one decimal place would be 9.7. And the unit is in meters. Okay.